algos are getting. So one such example could be that which movie you would like to watch, and then how this data gets processed is there are first the top 10 recommendation, that is how people are watching and what are the top searches people doing, what are the top movies people are watching on these algorithms, and then based on your likes and dislikes of genres, which movies you've checked, just a small snippet of a movie, and all these data points get captured and they basically tells you what is the best fit next movie for you. Now, the kind of data that these algorithms use are classified into two sections. One is explicit data and the other is implicit data. Now, explicit data is basically captured based on input that you are giving to the app. Let's say you watched a movie and you rated that movie. Or let's say you were on Amazon, you bought a product and then you rated, you commented how it was, you reviewed that product. That is an explicit input that you are giving to that application. Whereas implicit is something that they infer from your behavior, which is something like whether you clicked on a particular product, you scroll down that particular page, or the time spent of that page, what did you search on that particular search bar of that app, what kind of genres you like. So all these are inferred from your behavior. So everything that is inferred, and you might not even know that that particular thing is tracked, it's basically tracked. So whenever you go on an app or a website, there's always a pop-up of whether you want to accept all cookies. So these cookies basically track all your behaviors, even if you're scrolling on the screen, which part of the screen you're clicking, which ads you're clicking, all these kind of help in categorizing you and what kind of user you are. And there's basically all the set of implicit data. And explicit data is basically what input you are giving. So both the data have their importance while building these kind of algorithm. Implicit data, although has a very large importance in building a very sophisticated algorithm, because that is based on your behavior, and even you might not be very sure about what your behavior is on such apps, but when you run these data through a particular algorithm, it can basically classify your behavior and map it to similar pattern with other users on the platform. And that's how they recommend you similar thing that a particular other user would have like selected also. Now, if I have to divide collaborative filtering, it is based on two approaches. One is memory-based approach, the other is model-based approach. I will be further deep diving what these approaches are, like as they've been memory-based, have been classified as user-based, which has primarily two techniques, either correlation or cosine similarity, and even item-based, that is also caters to based on the similar technique of correlation and cosine similarity. The model-based approaches captures clustering, which is also called sometimes as content-based collaborative filtering. And the other is matrix factorization. And matrix factorization is one of the most used algorithm across any company or any platform that you would see. They have just enhanced it to their use cases more and more, and then the more and more data they keep on inputting to this kind of approach, the better the model gets and the more better recommendation you see. Another additional to matrix factorization now is the neural part of it. So the neural nets, when they are being used for matrix factorization, that even enhances your experience on these applications. Now, what is user-based collaborative filtering or memory-based collaborative filtering aspect where a user is involved? So when your preferences are matched to another user on what he is watching. So let's say you watched you ran 3 songs on YouTube, and there is another user on the app who has watched those 3 songs plus 2, 3 more songs, maybe of a similar genre, maybe of a different genre. So what recommendation you will get, that because your pattern matches to this particular user, you will also be recommending those songs that you haven't seen, but that user has already seen. It also goes down to movies or any interest, products that you scroll on Amazon or Flipkart, any app that basically gives you a suggestions of anything. That is how it works. Now, item-based collaborative filtering is when, let's say you watched or read a particular book or you bought a particular book on Amazon. Now, the genre of that book or the category of that book also covers a lot of other books. So when you are matched item wise, or your mapping is done item wise, then you are recommended based on item, And then let's say if a person, I've given a very shrewd example of, if you've seen that Lord of the Rings book, then your recommendation will also be something related to fiction. That could be a Game of Thrones book or a Harry Potter based book. So that's how it works. And when these two techniques, let's say you get an output from a user based approach and you get an output from an item based approach, they both are collaborated together. They both are weighted that which for which particular item or which particular thing you are getting a higher score. That is how your recommendation is sorted into. So that's how these kind of approach works. It's a very basic concept. Even uh, if someone has to recommend something to any other person, we also give a word of mouth suggestion based on these kind of things only, that I like this thing and you have a choice similar to me. Maybe you should also try this because I also like this particular movie. So that's how like user based approach works. Moving towards the clustering or the content based approach. Now for this approach, as you could see in this particular thing, the data, or in the user based or item based techniques, the data I was using was only a single input. Basically, it was either your rating for a particular movie, have you watched that movie or not watched that movie, have you listened to that particular song or not that listened to that song. So basically, if you want to think of your input, it's like 1 or 0. It's like a binary input that you are feeding into this user based or item based approach. Whereas for a clustering or a content based approach, your data can be multifold. It can have ratings, it can have views, it can have your page clicks, time spent on pages, reviews by other users, and comments that you give for so it basically covers both aspects of explicit and implicit data. And when you do a clustering approach, it basically categorizes similar or classifies similar users together. So when you have when you run a clustering model and you get a cluster of, let's say, 10 users who watch, let's say, 6 movies same, but there are few more movies that one of the user hasn't seen. So it's an easy recommendation that if he has liked those movies, there is a very high probability that he's going to like those movies as well. So yeah, this I was talking about clustering. Now moving to the matrix factorization. All the challenges of the above three approaches are that if your data is very sparse, or let's say very less inputs are in your data, the above three approaches tend to fail. Like if you don't have a rich data, like if you have too many nulls in your data, let's say you are a very new user on the platform, and you only hardly watch couple of movies on Netflix. So how should that couple of movies help you suggest a new movie out of it? So what kind of data is needed for this, and how does this approach differ from other approaches? So the kind of data that goes in matrix factorization is even larger than it is in clustering or item or user based approach. It basically has all the data inputs that you've given above three techniques, plus that what was your last watched movie, last watched song, last heard song, where did you scroll, how were you scrolling, how much time you were like it's every aspect of your behavior in the some or the other form is captured in the data. And all these data are basically either created into a binary format or a continuous variable format, because categorical input or categorical column does not work for this approach. So basically have to create few more columns of to feed into this particular approach, but your categorical data will not work with this particular approach. Now, the basic aspect that it tackles is the sparsity in the data, and even scaling it to a large audience. So for all the above three approach, it takes a very long time if you're running, let's say, on a billion user base. So YouTube or Netflix or any other app, Amazon, they have a huge user base on their data, and there are a lot of prospects that keep on coming. So you have to even suggest for a person who's coming on the platform for the first time. So what kind of data they use? They use, like, let's say they had suggested for 100 new users coming to a platform, they had suggested X items. And what was their response for those X items? They use that to train on the new prospect that is coming. Whereas when you have to do this on the above three approach, that is not possible, because it primarily caters to what you have seen and what you have selected. It's more on the explicit side of data, not on the implicit side of the data, and not reliant on how other users are doing. Moving forward, I will first talk about user based and item based approach, although I will be combining them and talking about cosine similarity in nutshell, and how this particular approach helps in creating a matrix that is further used in recommendation. Right. Now, cosine similarity approach, you guys can also drop your questions and I will try to answer all of the questions once I cover this particular slide and even at the last of the session when we are done. The cosine similarity approach basically helps us in giving a particular score of how two users are similar or how two items are similar. So the data input that is required is basically, we'll do a dot product matrix of this. So if you know about what is a cosine function, it is nothing. It tells what is the angle between two vectors. So if the angle between two vectors is 0, that is they are highly similar. You get a cosine value of 1 as an output. Whereas if they are highly differentiable, the output will be in a negative side. It could be -1. So that means you are highly different from that particular user. Now, what I kind of data that you can prepare, there are multiple ways to prepare data for this. You can use any kind of metric that you feel is a good metric to compare to users. So let's say if I am giving you an example of a project that I had worked on, was which telecom plan to recommend to a new user coming, or let's say someone was on a very old plan of a particular telecom company. If they have launched a new plan, whether it is a fit for him or not. So we match the attributes of his usage behavior, how much data packs he uses and everything. That kind of data helps in understanding whether a new plan, what kind of new plan can be suggested to this particular new user. So a user item matrix is creating basically nothing. You have all the user 1, user 2, user 3 data on your as your rows. And the items is basically, if I'm talking about Netflix, it will be movies. If I'm talking about Amazon, it could be products. If I'm talking about YouTube, it could be songs. So the value in these would be whether you've watched it or not, whether you've rated it or not, or it could be even what is the rating you have given. So, but it has to be in all the columns, it has to be consistent for this approach to work. It cannot be you have a binary in one column for one particular movie, whereas you have ratings for the other movie in a different. So this particular thing might not work because you have to be consistent in terms of having a binary data for this. Now, what it does is, when you apply cosine similarity from two metrics, let's say one was a new user matrix, which have watched very few, listened to very few songs on YouTube, and whereas the other users is a good, rich data where these have or watched a lot of movies or seen a lot of videos or heard a lot of songs on YouTube. So this particular aspect of the data has to be very rich, and the other data can be sparsely populated, where you want to recommend these users. Now it will, when you run a cosine similarity on this particular thing, it's basically nothing but just doing a matrix multiplication and capturing whether how much you are similar to the other user, and it will create another matrix which will give you a score between 0 to 1, whether how much you are similar to that particular user. So let's say if you can put any threshold in there, let's say I've taken an example of, if a cosine similarity score of 0.6 is there, you can, so cosine similarity works in the similar way how your correlation would work, Pearson correlation would work. So you can even use correlation, how you run correlation on your ED and all. It's a similar approach. It's just that you need a score of similarity with another user. So you can use cosine or either Pearson correlation. So if I'm talking about cosine similarity, you can replace that with Pearson correlation also. Both the approaches will kind of give you a similar result. Now, if I talk about the second matrix that you will get out of it, is basically a scored matrix. I've highlighted the fields where you match to a particular user, and it shows you a particular, like let's say if I'm talking about user 4, you match to C1 user because he got the score greater than 0.6. Also, 0.6 was given to also against C6. Now, what are these C6 users or C1 user watching? So let's say I pick an example of C6 user. He was kind of watching P1 and P6 products, and then you basically suggest them a score of, these are the kind of project that this user was watching and that can be recommended to you. So if you go back to what I was talking to, this is more of a user-based approach of collaborative filtering, because here you are looking at what a user was watching, and that's what you can suggest to this particular user also. Whereas it has also matched to C3 also, but C3 maybe had a plan, different plan, sorry, maybe had watched a different movie or something else. You are fairly matching with him, so your recommendation can be ordered in that way also. So when you run this exercise on a huge set of users, you can basically get a matrix out where you can sort them based on the cosine score that you are getting. And when you score them, it would look something like this. So let's say for a particular product, you were giving R1, basically R1 being that was recommended as the first thing, R2 being the second thing, and R3 being the third thing that was recommended to you. Now, if you scale this on a large data set, it looks a much more enhanced and much more understandable format. This is for, like, say, you take an example of 6 users, but these kind of algorithms run on a very large set of data where you have a million of data on which you look, which have already been on the platform, and 1,000 set of users for which you want to test this particular thing. So current plan users and new plan users, I've just taken an example of, let's say it was a movie data. So someone who was a new plan, had already a new plan, and for some you have to recommend a plan. So this is the approach a user to user metrics would look like. This will give you what a new subscriber, they would pick, what kind of plan they would put, what kind of movie they can pick. So you can interchangeably use plan against any kind of item that is there. So it will correspond to, if you are on an app that is an e-commerce app, the plan will correspond to a product. If you are on a Hotstar kind of platform, the plan will correspond to your subscription plan or something, like different options that are available. This is, I've just suggested the formula that goes behind the cosine score, and that's how your recommendation is generated. And this is like a basic niche formula that you will find across every cosine similarity recommendation approach that is being used. This is the basic approach that even in the, you can replace it with the Pearson correlation score, so that will also give you a similar output for this particular thing. It is the thumb rule is that you should only suggest top 3 recommendation out of this, because there are a lot of user which you match with, but you have to concise it down to what are the top 3 recommendations. So that depends on how you sort the ranking when you get the score out of the cosine similarity matrix. Again, last pointer I have suggested that you can even relate or replace this with the Pearson correlation approach as well. I'll just probably check if there are any questions. All right, done as of now. Right. So moving forward, I wanted to touch base on a very important concept, because this will help you in understanding how matrix factorization works. And I had touched base on this kind of approach in my last session of PCA as well, on how these latent factors or principal components are created or factors are created out of a large set of columns. Because if you don't concise your columns of different values, different kind of attributes, different kind of data types into a simpler form of a continuous variable matrix, your model is tend to fail more. So you will always, it's a good practice to concise your data as small as possible, and PCA, later factor matrix factorization, SVD, single value decomposition, these are few approaches that are widely used to reduce the complexity of your data, reduce the size of your data, but the information does not lose. So the information retains, and but you are able to run your model faster, but it is in a very concise form. The latent factor is basically a factor that is created out of a large set of columns, but it indicates to a particular attribute of those columns that have been selected. So I've taken a very basic example of, let's say this is a subscriber or genre attributes, or like a, if you go on Netflix, this is kind of a data that you might see, like these are genres, their clicks, review, times spent on that particular movie or on the web page, and number of times you watch. This is a basic columns that have thought of and would be there in the data that is been used for a movie recommendation kind of algorithm. And I can't, and these are, this is just, I'm taking an example of one movie. So if there are, let's say, 10 columns for one movie, there could be 1,000 or 10,000 movies on a platform, and 10,000 movies would have all these 10 columns. So you can imagine 10,000 in tenfolds how many columns would be there. And when you have such a rich data, it is always advisable to go with a matrix factorization approach, because you always have a capacity to reduce the complexity of your data, and all these are not available in clustering or a user or item based approach as well. Now, how these latent factors help is um, all these, let's say, action, mystery, horror, comedy. I can already see these cater to genre. And when I do run a latent factor analysis or a PCA on this particular data, it will give me a smaller data set of, let's say, one column, which I can, when I check eigenvalues, or when I check which weightage this particular component or which this particular factor is giving to, it will be related to these four columns, because it's tagging it to all genres, because the how user have been tagged to this, they show a similar pattern, and all the columns will indicate that this is probably related to a genre column. Although when you run matrix factorization, this part of the entire algorithm is a black box, but this is what is running in the background. I'm taking a very niche example to help you understand the concept of it, but that's how your latent factors are created. It's basically a combination of columns that help you indicate to a particular attribute, and you just concise them. Now, engagement could be related to clicks and review that you are doing. Interaction could be related to the time you spent on the page or the watching the movie and the number of times you watched a particular thing. So that's how you drill down from 8 columns to 3 columns, and probably an 80,000 column can even be further drilled down to 3 or 4 columns. So this entire exercise helps you reduce the time that you're gonna spend on running your model and get the output out. So it's basically a utmost necessary thing to be carried out before you're running this kind of algorithm. Now I'm taking the example of ALS matrix factorization, of it stands for alternating least square matrix factorization approach. It is based around the concept of how your PCA mathematical approach is based on. It's based around the single value decomposition principle, which I will obviously be walking you through when I'm talking about this approach. But it basically, what it does is it takes a large matrix, creates it, predicts the value where it is there are null values, and helps you create a new matrix with the values which were not initially present in the data. And the other approach, when you're talking about PCA and how it is related to the PCA approach, it is basically, it also creates the latent factor or the component that is also part of that particular approach. So that is where these two approach have some overlap in between them. Now, ALF is an iterative optimization process. When I'm saying iterative, is basically the metrics keep on multiplying with itself till it is able to retain the minima. So if you know about the concept of any regression model or any least square model, basic regression techniques, they always try to attain a minima. Is basically when your error is minimum. So even this approach tries to generate values for the user that have not viewed a particular item or not seen a particular item or not watched a particular movie, and give a particular value to those corresponding users. And how it does it, keeps on running into an iterative loop, keeps on generating a best fit value for those users. And whenever the error for those users tends to be minimum, that is where the algorithm stops and it gives you an output out. So moving forward, subscriber feature metrics. I've again taken an example of, let's say you are on a Netflix app, you have a number of subscribers. You can divide it, you can call that your data is divided between train and validation, but how I have divided it is basically validation set is someone where you will be suggesting those movies, and train is where people have already seen certain set of movies, and these movies could be new movies. When I'm talking about the data set, how it would look like, it will have some features like, as I was talking, what was your last viewed movie, what was your movie that you clicked on, what kind of genre you watched, reviews, ratings, time spent, and every other aspect of your behavior on that app can be basically covered in other features. Now, item flags is whether this movie should be suggested or not. So for the trained subscriber, it would be liked by those users, and the like you can, let's say if there is no like, people are not liking that movie explicitly, you see whether they've watched it fully or not. So that is also sometimes taken as a proxy that that person has seen that entire movie, is basically he stick to that movie because he liked. So that's also considered as one flag when you are kind of building these algorithms, and you can create, always take these kind of proxies when you're building these. The latent factors, as I again told you, there were genre available, there were engagement metrics available, interaction metrics available. So those latent factors help this matrix factorization approach understand I am an X user to which other user my pattern is matching, my user behavior is matching to. So that will help them understand that if that particular other user has seen these set of movies, they should also be recommended to me in some order. So now I've given this example. Now later factors are also tagged against the item flags. Is basically how this matrix is multiplied and keeps on regenerating the values. Now I've given an example of that. The null values over these, basically there were no values whether you watched or not. It gives a probabilistic score between 0 to 1. This approach will always give you a value between 0 to 1 only if you have a continuous data set. Again, I'm telling you, it won't take categorical value and probably throw you an error when you're running it on Python or let's say R. But if you are giving a continuous input between 0 to 1, or even putting a binary data set, that is the best possible scenario. And then it will also give you probabilistic output between 0 to 1 of what is your probabilistic score for that movie. So for the user that were not recommended anything or had not seen certain items, they were given a recommendation score for a particular movie, and then it will pop up on their screen. And that's how the suggestions that you see on YouTube of songs or videos, everything, it goes through this particular kind of algorithmic approach, and that's how your suggestions are ranked. So whatever is ranked is given a very high score to you, is ranked on top, and subsequently the lower ranking options come on your screen. Now, as I've told you, the subscribe it is, you can basically understand the subscriber feature matrix is created on a huge data set. There are other. I've also taken an example of a telco industry, as I was giving in the previous slide, that they could be based on the usage, revenue, device type, what you are using. So maybe people with a similar device may tend to kind of, they watch YouTube movies of a higher quality of something like that. So that is also one aspect that is considered in these kind of data. So someone who has an iPad compared to an Android mobile, their recommendation of what kind of movies they videos they are recommended also differ. So some things run better on an iOS platform, some things are different on an Android platform, and in what quality they are available also matters. The app experience obviously on two platform also differ. So that also uh, gives you a certain kind of recommendation. The device and the platform, OS platform that you are using also governs what recommendation you are going to get. The last thing that I want to tell you about this approach is that it runs very well on the very sparse data. So I did not have any recommendation or interaction of these user that I had to suggest recommendations for. They had not interacted with the platform much. You have to recommend something to them so that they engage with the platform more. So basically, recommendation algorithm are focused on the prospects more, because that is from where you want your engagement more. Most of the users on the platforms are regular, they keep on coming back. So for them, the recommendation algorithm works pretty well. They tend to take more recommendation and suggestions, and even those recommendations might not be the best fit for them, they tend to be more engaged with the app because they've already fallen for the UI or the experience that is there. But those who don't retain well, for them the recommendation algorithm has to be powerful. Moving forward, I've taken an example of how an existing system in, let's say, YouTube would be working right now. So there is obviously a video corpus, that is the entire video set that is there. There is a user history and context data, how whether the user has been engaging by commenting on videos and all those kind of data. And this then there is something called candidate generation. This candidate generation is nothing but what matrix I was creating in this approach as the last matrix. So if let's say a particular user has watched something and there is a huge video corpus that he hasn't watched, then what would he tend to watch? What are the score that you, so candidate generation is something that is being taken care of, that if you are watching X set of items and other user are watching X set of items, what how your candidate generation matrix would look like. So that is, this is nothing but a data set only, which is created based on existing video set that you haven't seen and your user history. Now, when you run an ALS kind of approach on this, you are ranked because there are other candidate sources which are basically the other users on the platform and they have already seen. The other video features data is basically what kind of videos you're watching, in what aspect ratio you like to watch. All these factors, they might not be very highly dependent on your user behavior, but these kind of things slightly impact in improving your recommendation. So as much data as you can get, it could be related to video features, it could be related to what kind of genre that you are watching, all these, and your behavior, last watch video, last heard song, all these kind of collaborate together and generate a rank for a video, and that's how you get a list of suggestions on them. And talking about the advancements that are being made are in terms of the neural side of it. So as I told you when I was talking in the previous slide, the latent factors were only created for the items or basically your behavior on the website. It was not, latent factors were not created on the users. So how users latent factors can be created is basically users that are interacting from the similar platform. Some are watching on the TV screen, some are watching on a similar device. So you can consider a very basic example that iOS users are in one latent factor, Android in one device, different device, iPad and desktop others. So that's how basic latent factor would look like. Whereas other aspects of how much time you spent on the website, that can also help you in relating the user, what geography you are part of. And when you enroll on a particular platform, they also take a lot of details. They get your email ID, they get to know whether you are a working professional or not, because they also tap your data from different sources as well. So basically then a user latent vector or a user corpus of similar user can also be created. Now, when you have a user corpus of which you can create latent factors out and similarly item factors, that can be embedded together, and that approach can only be done not by an ALS, which is basically you need to have a user item matrix, whereas in which you can have a both item matrix, a latent vector matrix and an item latent vector matrix, and these can be combined in a neural net format, and those layers can obviously like deduce you whether this particular movie or this particular item is best fit for you or not. So it's a very complex approach. We can probably have another session on talking about how this entire architecture looks like, what is the mathematics involved behind this neural collaborative approach. But for letting you know, there are advancements made on these side, and as it more your data increases on this platform, these neural model keeps on enhancing their efficiency, and you keeps on seeing the recommendation that you're getting on Instagram or YouTube or Netflix are improving day by day. So that is how the more time you spend on the website or applications, the more better recommendations you are keep on going to get moving forward. So yeah, this was more or less about the recommendation system and algorithms. The two approaches you can, there are a couple of data sets available on Kaggle on which you can primarily apply these techniques and see the result for yourself, how these work. And cosine similarity is the first thing you can start off with to basically understand how this thing work, and moving forward to ALS matrix factorization and then to neural approach. So all these have different mathematics behind involved, and you will get to know once you run these kind of algorithms by yourself. Yeah. I'll probably take some questions now. So again, latent factors. When I talk about latent factors, basically, if you want to concise a group of columns into one column, basically, I have a lot of columns that cater to genre of a movie. Now there will be like 20 genres of a movie, but that all can be combined into one particular column. So concising them from 150 to 1 is how you create a latent factor, and that latent factor helps in governing what you are recommending. And it also, when you are reducing the size of your data, the speed of your model increases. So that is the purpose behind this. How to solve a cold start problem? Please give some approaches. So yes, cosine similarity is one go-to approach. You can prepare a data in which you have users on in all the rows and your items, or let's say movies, on the columns. Let's say there are 100 movies, 100 columns there, and just the value of 1 or 0 in them. And you will get to see the user who have similar taste of movies are also recommended a further movie that is also of their type. So that a particular approach would work. I'm not sure where you want to know about association rule mining, Monu. So probably I'll look up into this, but it's kind of not um, related to the concept I was talking about here in the session. Yeah. If there are no questions, I think we can end the session. And I would like thank all of you guys for being part of this DataHour series and being part of the multiple sessions I've been conducting with Analytics Vidya, and I hope to see you soon for the further upcoming sessions that will be also along the same line of machine learning approaches and the use cases that are being solved across industries. Thank you so much.
Thank you, Varun. And for everyone others, there's a feedback poll in which you can give your response. And the next DataHour session is on 21st of January. Kindly do check in the Analytics Vidya website for more such DataHour sessions. I hope you guys have filled in the feedback poll. If not, I request you to please fill in the poll about feedback, as it helps us to conduct more such sessions. And if you wish to conduct a webinar or are facing any difficulty in registering, connect with us at editor@analyticsvidya.com. And the recording of this session will be available within 2 days on our YouTube channel, that is Analytics Vidya. And we'll be back with another session of DataHour on 21st December, 21st of January, and the link is in the chat section. Till then, bye bye and keep learning.